In this video, we will start Chapter 9, Estimation. There's two major purposes of estimation. One is to use the sample data to estimate the population proportion because it's not really possible to study the whole population. So we study the sample, and based on the sample, we make some inferences about the population. The second major purpose of inferential statistics is to estimate the sample size. If you know how much error you are okay with, then how large sample you want to collect to be confident about the results you are sharing or providing. So estimation, we will be estimating the population parameter using the sample statistic. Okay, population parameter will be estimated using the sample statistic. If you recall from beginning chapters, we talked about sample statistics and population parameters. Sample statistics and population parameter. Population parameter. Sample statistic and population parameter. Sample statistic for mean, sample statistic is x bar, population parameter is called mu. And for proportion, what is a proportion? Proportion is, for example, if I go to Yuba College parking lot and I want to find the proportion of red cars in the parking lot, so that would be equal to the number of red cars divided by total number of cars. So proportion sample statistic is p hat, and population parameter is p. And for standard deviation, sample statistic is lowercase s. For population, it is sigma. Okay, so we will be using sample statistics to estimate the population parameter. Statistics are calculated, parameters are estimated, because we really cannot work with the whole population because it's too large, it's too time consuming, it's not cost efficient. So we work with the samples, several small samples, and based on those samples, we make inferences about the population. Okay. First definition is point estimate. What is a point estimate? Point estimate is your sample statistic. So point estimate is either your sample mean or your sample proportion or sample standard deviation. So point estimate can be sample mean or sample proportion or sample standard deviation. Our first section, we are going to focus on sample proportion only. So in this section, we're only going to discuss sample proportion, but in the next section, we will discuss sample mean, and the following section will be sample standard deviation to use these to estimate population parameters. Okay. So the point estimate is going to be different from the population parameter. Now it's important to realize if I have a sample, if I want to estimate the average height of Yuba College student, and I sample my class of 30 students and I estimate their average height or calculate their average height, that is my sample statistic. And I want to estimate the average height of Yuba College students. So I'm talking about thousands of students, not just 30 students in my class. So in order to do that, my 30 students average height will not be same as the average height of Yuba College student, because population is different from the sample we're talking about due to sampling error. There's no way for me to find out the average height of Yuba College student, because if I start doing that today, it might take me a month to get to all the students. By the time some would have dropped, some new students would have joined, late classes would have started, things would have changed. So we work with the samples. We use the sample statistic, either sample mean or sample proportion or sample standard deviation, to estimate the population mean or population proportion or population standard deviation. And the sample statistic is called point estimate. Okay. A confidence interval is an interval estimate with a specific level of confidence alpha. So usually for the confidence interval, there is a confidence level associated. Confidence level can be 90% confident, 95% confident, 99% confident, 80% confident, 50% confident. It could be any level of confidence. Most commonly used is 95%. And if the confidence level is not given, go with 95%. Okay. 95% is the most commonly used confidence level. If it's not given, go with 95%. Okay, maximum margin of error for the estimates. So maximum margin of error or maximum error or margin of error for the estimate. Now there is some margin of error in the estimate. For the confidence level, if it's not given, always use 95%. And the margin of error does depend on the confidence level as well. In the previous chapter, we talked about Z alpha critical value. Critical value Z alpha. So Z alpha was the one that had alpha area to its right. So Z alpha had alpha area to its right. This had alpha area to its right. Now we will be talking about Z alpha over 2 here. So we'll be talking about Z alpha over 2. Okay, based on the confidence level. What does that really mean? So that means if we have 50% confidence level, before we talk about this table, I want to quickly share. If I ask you to estimate my age, 99% confidence level, or if I say estimate my age within plus minus 1, that will be extremely hard for you, and unless you already know. But if I say estimate my age or guess my age within plus minus 5 or plus minus 10, now you have a bigger margin of error. You can tell me your answer with the higher confidence level. So when you have a bigger confidence level, you can be more confident when your margin of error is bigger. When your margin of error is smaller, you won't be so confident guessing my age within plus minus 1. So 50% level of confidence means 50% area is in the middle and the remaining 50% is on the side. And that remaining 50% will be divided by 2 because it's actually being split in 2 tails. So that's what 50% level of confidence is. So now we want to find out Z alpha over 2. Z alpha over 2 is the critical value used in the formula to calculate margin of error. So we are focusing on just Z alpha over 2 now. And pretty soon we're going to look at the margin of error formula. Okay, so Z alpha over 2 is the critical value that has 0.50 divided by 2, which is equal to 0.25. So the critical value that has 0.25 area to the right is this. Okay. So if there's a confidence level which isn't given in the table, you will have to find the value. You'll have to divide the confidence level by 2 and then look up the area in the, you will not have to divide the confidence level by 2, but the remaining area by 2. Okay, this is not confidence level by 2, remaining area by 2. So estimating a population proportion, there's a few conditions, requirements, simple random sample, conditions for binomial should be met. We should have independent trials, fixed number of trials, 2 possible outcomes, constant P and Q. There's at least 5 successes and 5 failures, and P has to be greater than 5 and then Q has to be greater than 5. Some textbooks go with NP greater than 10 and Q greater than 10, just to make sure we have large enough sample. Okay, just to make sure we have large enough sample. P hat is X over N. P hat is calculated from your given sample. And I'm going to go directly to the formula, but you read the supplement for more information. Margin of error formula is here. So E is equal to Z alpha over 2 and square root of P hat Q hat over N. Z alpha over 2 square root of P hat Q hat divided by N. Confidence interval for population proportion is expressed as this. So once we find the E, we will use the P hat. We will use the P hat to find the upper bound for the population proportion, and we will also use the P hat minus E to find the lower bound. So again, this is population proportion. Okay, and this is sample proportion, and this is margin of error. Okay, so the wiggle room you have to deviate from the estimate for your population. Okay, so we can also express it as P hat plus minus E. Instead of writing in this form, we can express it in this form, or we can express it in the confidence interval form in parentheses. Z alpha over 2 is the critical value where a z-score that has alpha over 2 area to its right. So this is a z-score that has alpha over 2 area to its right. Alpha over 2 area to its right. Okay, find the critical value corresponding to 95% confidence level. So for 95% confidence level, that means 95% area is in the middle. This is 95% area, and the remaining 5%, so alpha is 0.05 because alpha and confidence level are together, they're going to be 100%. That's all of your area. Alpha is 0.05, alpha over 2 is 0.05 divided by 2. So this is going to be 0.05 divided by 2, 0.05 divided by 2. So now we are looking for the z-score that has 0.05 divided by 2 area to its right. 0.05 divided by 2 is 0.025. So what is the z-score that has 0.05 area to its right? Now remember, your z-score table does not give you area to the right. It actually gives you area to the left. So we can either use the symmetry and get this z-score, or we can find out if it's got 0.025 area to the right, how much area is to the left, and then read the table. Okay, we have learned how to read the table in the chapter 7 when we talked about normal distributions. So same z-score table, and it's going to be 1.645 is the z-score that has that is not correct. It's 1.96. 1.96 is the z-score that has 0.025 area to its right. Let's see if we have the formulas here. What is the z-score that has 0.025 area to its right? 0.025 area to its right. Let's find out 0.025 in the body of the table, because so I'm going to use symmetry. Remember this, we are looking for the z-score that has 0.025 area over here, and that is the area, but either my table does not give me area to the right, so I either have to use the symmetry. So let's first talk about how to use the symmetry. So I can look for this area 0.025 in the negative z-scores, that is 0.025, looks like right here. So 1.96 is the z-score. So that's going to be negative 1.96. But I'm looking for the one that has 0.025 area to its right, not to the left. So I can do it in two different ways. One way I can think about, if it's got 0.025 area to the right, how much area is to the left? So I can do 1 minus 0.025, and that turns out to be 0.975. So this will be 0.975. All of this area is 0.975. And I can look at 0.975 in the positive z-scores. 0.975, that is right here. So again, 1.96 is my z-score. Okay, so going back to the notes, 1.96 is the z-score that has 1.96 is the z-score that has 0.025 area to the right. Okay. Let's look at another example. Find the critical values corresponding to 90% confidence level. Okay, for 90% confidence level, we are looking at 90% area is in the middle. The more confident you want to be, the bigger the margin of error. Okay, we've talked about it. If you want to guess my age with the higher confidence level, then you probably want to guess within plus minus 5 or plus minus 10. You don't want to guess within plus minus 1. So 90% area is in the middle. Alpha is going to be 1 minus 0.90, which is alpha is 0.10, and we are going to find that alpha is being divided into two tails, so 0.10 divided by 2, 0.10 divided by 2, 0.10 divided by 2, 0.10 divided by 2. Okay, so that is going to be 0.005. 0.0, I'm sorry, not 0.005, it will be 0.05. 0.05. So what is the z-score that has 0.05 area to the right? Go ahead and look up in the table. Either you can look up in the negative z-scores and just make it positive, use the symmetry, or you can find out if 0.05 is area to the right, then the area to the left would be 0.95. Search for 0.95 in the positive z-scores and then find the z-score. And it's going to turn out to be, let us see, 0.05 area to the right. So I'm going to look for 0.05. If it's in the table, if it's not, we'll go with the closest. And sometimes the special values are actually given at the bottom as well. Let's see if this is given. Okay, here it is. So we are given the confidence level. So in this case, we're looking for 90% confidence level, and we're given that the critical value z alpha over 2 is 1.645. So I'll be using 1.645 here. Or let's read the table. How do we read the table? 0.05 area to its right. I'm going to look up 0.05 area to the right. Looks like here. These are the two values that have 0.05 exactly in the middle. So between 1.64 and 1.65, and it turns out to be 1.645. Okay, so 1.645 is the z-score that has that is the critical value for 90% confidence level. Steps to construct confidence interval for population proportion. We're about to look at some examples. So here are the steps. The first one, verify the requirements are satisfied. Actually, most of the time the requirements will be satisfied. Find the z alpha over 2 using the z table. So critical value, z alpha over 2. Again, you will be given confidence level. That's your area in the middle, whatever confidence level is. And then the remaining is alpha. Alpha is divided into 2. So alpha is 1 minus confidence level. And then alpha over 2 is in two tails. In each tail, you have alpha over 2. And then use the z table to find the critical values. Here's a formula to find the margin of error. Z alpha over 2 square root of p hat q hat over n. And then compute p hat plus minus e and round your answers to 3 stick figures. Don't forget to interpret your answer. Interpreting is very, very important as well. So what does interpreting means? That means we would be saying at the end, we are 99% confident that the true value of population proportion P lies between, for example, these numbers. Um, so if we select many samples, so this is what interpretation is. If we select many samples of the same size, 30 students from our population, 99% of the confidence intervals will have the true population proportion. Okay, if we select many samples of the same size, 95% of them, or 99% of them in this case, will have the true population proportion. Here's an example of wrong context. That's I'm leaving for you to read. So context is interpretation is very important as well. Okay, so these 1 minus alpha are the likely values and alpha over 2 are the unlikely values. Here's some examples already worked out for you, and let's go on to the ones that are not worked out and let's do them together. A study was conducted in which 1,000 randomly selected Americans were asked if they believe the minimum wage should be increased. Okay, if they believe the minimum wage should be increased, a total of 600 Americans said yes. Construct a 90% confidence interval. So this is important. If you are constructing a 90% confidence interval or 95% confidence interval or 99% confidence interval or 50% confidence interval, your critical value is going to change, and based on that your margin of error is going to change. So be cautious about the confidence level you have. Okay. So construct a 90% confidence interval for proportion of Americans who believe the minimum wages should be raised. Now we are constructing a confidence interval for entire population, all the Americans. Okay, so let us start. What is my sample size here? 1,000. Out of that, how many people said yes, increase the minimum wage? 600. Okay, what's going to be p hat here? P hat will be x over n, which is 600 over 1,000, and that turns out to be 0.6. Okay, now let's see, we want to construct the confidence interval, so we need to find the margin of error. But before that, what is the critical value z alpha over 2? And since we know p hat, we also going to need q hat in the formula. How do we find q hat? Q hat is 1 minus p hat, which will be 1 minus 0.6, and that's 0.4. And we do want z alpha over 2 as well. So let's go ahead and think about z alpha over 2. My confidence level is 90%. That means this is the area in the middle, 90%. Each of the tail has a remaining 10%. If the 10% is divided into two tails, then each tail has 0.05. Now go to the z-score table and find out the z-score that has 0.05 area to its right. Z-score that has 0.05 area to its right, and we just talked about it. It's also given on the bottom of the table. Z-score that has, for 90% confidence level, Z-score is 1.645. So 1.645 is going to be my Z alpha over 2 in this case, 1.645. Okay, let's go ahead and calculate the margin of error next. Margin of error is Z alpha over 2 square root of P hat Q hat over N. So all I have to do is just plug the values I know. Z alpha over 2 is 1.645 square root of P hat. How much is P hat here? P hat is 0.6, Q hat is 0.4, and divided by N is 1,000. Go ahead and plug this into a calculator and calculate what does that turn out to be. And I got, using a calculator, I got 0.0255. So this is my margin of error, 0.0255. Now it is time to estimate the actual population proportion, and we've talked about, to estimate the population proportion, we would be doing p hat plus e, p hat minus e. So p hat is already given in the beginning, so that's 0.6 plus 0.0255, this is a 0, and then 0.6 minus 0.0255. Use a calculator and it turns out to be 0.574 less than p less than 0.625. Okay, so this is my confidence interval. We can also express it in terms of percentage, in terms of parentheses. So we can express it as 0.574 comma 0.625. It's really up to you. How do you want to express it? Okay, 0.574, 0.625. All right, so now how are we going to interpret? So we're going to say we are 90% confident. We are 90% confident that the proportion of Americans who believe minimum wage should be increased, minimum wage should be increased minimum wage should be increased lies in, so we can express it in terms of percentage as well, 57.4% to 62.5%. So if we create many uh, surveys or samples of 1,000 people and we survey them, about 90% of them would contain the true proportion of Americans who believe the minimum wage should be raised. 90% of those confidence intervals, okay, like this one. All right. Another example, construct a 99% confidence interval for the proportion of Americans who believe the minimum wage should be raised. Now, again, it's very similar to the last one. The only thing that's different, it's a part B of that problem. Only thing that's different is your confidence level. So nothing else changes. Your P hat is still 0.6. Your Q hat is still 0.4. The one thing that is going to change is the Z alpha over 2. So how do you find Z alpha over 2? Alpha would be 0.01 here because we have 99% confidence level. 99% confidence level. Alpha would be 0.01, right? 1%, the remaining 1%. So alpha over 2 is 0.01 divided by 2, and 0.01 divided by 2 is 0.005. So I'm looking for the z-score that has 0.005 area to the right. Either look at the bottom of the table or read in the table. The z-score turns out to be 2.575. If you want to be more confident, remember your margin of error will be bigger. You want to be more confident, your margin of error will be bigger, your confidence interval will be wider. Like I asked you, if you want to guess my age within plus minus 1, your interval will be small. If you want to guess my age within plus minus 10, you have a bigger margin of error, your interval will be wider now. Okay, so let's go ahead and find margin of error now. Margin of error, z alpha over 2 square root of p hat q hat divided by n. That turns out to be 2.575 square root of p hat. P hat is 0.6. Q hat is 0.4 divided by 1,000. And that turns out to be 0.039. 0.03989. 0.03989. Okay, so that's my margin of error. And we have talked about earlier that to estimate the proportion for population, we are going to use the point estimate. Point estimate is the value you get from the sample. Point estimate is the value of proportion you get from the sample. So your point estimate is p hat. This is your point estimate. Okay. So p hat is 0.6 minus 0.03989, p less than 0.6 plus 0.03989. So we will be adding and subtracting the margin of error from the sample proportion. So that turns out to be 0.560 rounded to 3 sig figures and 0.640 rounded to 3 sig figures. All right, and that's our confidence interval. So we can say we are 99% confident that the proportion, we are 99% confident that the proportion of Americans who believe minimum wage should be raised, who believe, my pencil is giving me trouble. I might need to fix it. Believe that minimum wage should be raised lies in, so again, we can express it in terms of percentage, 56% to 64%. You see, your interval got wider. When you're more confident, you have a wider interval. More confident, wider interval. Next problem, I would like you to stop here and try example number 4. A sample of 500 nursing applicants include 60 from men. Construct a 95% confidence interval for proportion of men who apply to nursing program. Pause the video, go ahead and try to write everything that's given and work it out. Come back and match with me. X is 60 here, N is 500. P hat is 60 divided by 500, and 60 divided by 500 is 0.2. Q hat would be 0.88 in this case, and our confidence level is 95%. Alpha is the remaining 5%, which is 0.05, and alpha over 2 is 0.05 divided by 2, which is 0.05 divided by 2 is 0.025. 0.025. So z-score that has 0.025 area to its right. What is a z-score that has 0.025 area to its right? Either read the table, or you can go ahead and the bottom of the table has this information, 1.96. You can also use a calculator for it. So 1.96 is the z-score that has 0.025 area to its right. If you're reading the table, you might have to use a symmetry, or you might have to think about, if 0.025 area to the right, how much is area to the left. Okay, so that's my z alpha over 2. We have z alpha over 2 is 1.96. Okay, let's calculate the margin of error. Margin of error formula is z alpha over 2 square root of p hat q hat divided by n. Square root of p hat q hat divided by n, and that's 1.96. That is too far. 1.96. Square root of p hat is 0.12. Q hat is 0.88 divided by n is 500. Okay, so that turns out to be, using the calculator, 0.02848. 0.02848. Okay, now I'm going to estimate the population proportion by using the point estimate, which is p hat, and margin of error, which is e. So plug in 0.12 minus the margin of error, 0.02848, less than p. No rounding until the last step, okay? Don't round in the middle. Take as many decimal places as you can, at least 5-6 decimal places, and then round at the last step. Now 0.09152. 0.09152. I didn't round it to 3 sig figures. We should round it to 3 sig figures, or however my math lab says, round it however my math lab says, but normally it would be 3 sig figures. This is a 1. My pencil is writing, I think I need to change the nib. 0.1485. 0.1485. Okay. We are 95% confident that proportion of men nursing applicants that proportion of men nursing applicants lies in let's see, 9.2%, approximately 9.2% to 14.9%. Okay, and that's all for this video. In the next video, we will talk about estimating the sample size. If you know your margin of error, how large sample do you need?